Hi everyone, welcome to Easy BTech. In the previous lectures, we discussed the types of DC generators and the problems on types of DC generators. In this lecture, I will teach how the EMF is induced, how the voltage will be build-ups in self-excited generator. So voltage building in self-excited DC generator. So from the previous lecture, separately excited DC generator means the field winding is excited with an external source. There is a variable voltage and the field current is flowing like this. Then the flux lines are produced by the field winding, which will cut the armature conductors. If the armature is driven with prime mover, then the generator EMF will be induced. Coming to the self-excited DC generator, what is meant by self-excited means the field winding of shunt generator or self-excited generator is excited by its own armature winding. That means that due to the EMF which is induced in armature winding, that only to produce the flux in field winding. Let us see. So the field winding is connected in parallel with the armature. I am taking a DC shunt generator and now it will be rotating with the help of a prime mover. The speed is maintained as constant. That too, it is a rated speed. So that is equal to 1500 rpm. Okay, and now I am driven this speed of the armature is maintained as 1500 rpm. Okay, for 4 pole 50 Hz, definitely the frequency is for 50 Hz and the speed is 1500 rpm. So initially what will happen, let us see. Some flux will be retained. Some flux is retained means some flux is present even if field current is 0. Even though field current is 0, some flux is present because of its material property. That means magnetic material property. We are using electromagnets. So if you go for the soft iron material, only 5% of rated flux is present. 5% of rated flux is present. If you use hard magnetic material, this is a soft magnetic material, and soft iron also. Hard magnetic material, soft iron material is that is silicon steel. And if you go for the hard magnetic material, 30 to 40% of rated flux is present. But if you go for the hard magnetic material, the hysteresis loop for the hard magnetic material is more. The hysteresis loss is more for hard magnetic material. If you go for the soft magnetic material, the hysteresis loop is less. That means the hysteresis loss is less. So what will happen due to the residual flux? It will cut by the armature. An EMF is generated in an armature. So Eg is equal to phi Zn by 60 into P by A. Once design is over, number of pole widths is constant, parallel path is also constant, 60 is also constant, Z is also constant, Eg is directly proportional to N phi. In this case, I am maintaining the speed of the armature is constant. Then Eg is directly proportional to phi is directly proportional to ISH. This is called the ISH. The current is delivered from the armature, and the current which is flowing through the load is load current. But if this is under open circuit condition, this value is equal to 0. But some part of the current is required to produce the flux, and some part of the current is required to meet the losses. Okay, now if Eg increases, ISH is equal to Vt divided by RSH. Vt divided by RSH, it is approximately equal to Eg divided by RSH. As generated EMF increases, then shunt current increases. That means field current increases. Field current increases. The number of flux lines are produced by the field winding is also increases. Then cutting action will be increases. Generated EMF is also increases further. If Eg increases further, again the shunt current increases. The number of flux lines are increases. Again the generated EMF still further increases. If Eg further increases, again shunt current will be further increases. Number of flux lines is also further increases, and generated EMF is also further increases. And this process will continue until the rated voltage is obtained. That means rated voltage is obtained. That is Eg naught. That Eg naught will be obtained. So if you draw the characteristics, Eg versus field current, Eg versus field current. So under no load operation and the machine is under off condition. The field current 0 means the machine is under off condition. The field current is 0. Some flux is present. The residual voltage will be present in the armature. So after that, the field current is slowly increases. Now it will be IF1. Again the generated EMF is increases. Let us say this is called the E2 and this one is E1. After that, again the field current increases. Yes or no? Again the field current increases. So again the generated EMF E3 is increases. IF3. So E4. So like that. The generated EMF will be induced. The buildup of voltage is like this. If you add all these points, then you will get the characteristics are like this. Okay, so this is a rated voltage. This is a rated voltage. If I am drawing the curve and represented with the dotted line, that is our rated voltage. And this type of characteristics is called magnetization characteristics of DC generator. Magnetization of characteristics of DC generators. And so what are the points to be noted, and what are the conditions? What are the conditions for buildup of voltage? Buildup of voltage. The first one is check that residual flux. If the residual flux is present, then the induced EMF, if the residual flux is present, it will generate the EMF. It will generate the EMF. That means the armature generates the EMF. If the connections, that means field connections, are not properly connected to the armature, residual flux is lost. Residual flux is lost due to retentivity property. So retentivity property, we will discuss what is the retentivity property while history classes comes. Due to the retentivity property, all the electromagnets possesses some flux, even field current is zero. This flux is called residual flux. This flux is called the residual flux. And if the field connections are wrongly connected, no further buildup of voltages. The connections are wrong. Connections are wrong. Buildup of voltage. So voltage buildup is 0. Then separate the field connections and excited with an external source. Then to establish, means to re-establish the flux. This process is called field flashing. This process is called the field flashing, and this is very, very important. Okay, and these are the conditions for buildup of voltages. And one more thing, the total circuit resistance should be less than the critical field resistance. And one more condition is the speed is greater than the critical speed. So I'll discuss one by one in the next video. Thank you guys.